given the graph of f, determine the solutions to f of x is less than 0. In other words, we want to find all the x values where the function is negative. Geometrically, that means to find all the x values where the function lies below the x-axis. And so from the graph here, we can see that when x is less than -4, the function values are negative, or when x is greater than 2, the function values are negative. The function lies below the x-axis for those intervals. Now we'll present our answer here in interval notation. In other words, all the x values in the interval from -infinity to -4, notice here I'm using a parenthesis and an open dot because of the strict inequality, union all the x values from 2 to infinity satisfy the condition f of x is less than 0. Solve 9 minus x squared is greater than 0. Now the first thing I notice is that this is a quadratic inequality. If we let f of x equal 9 minus x squared and graph that, we would notice that this function would be a parabola opening downward. And so the question asks, when is this function greater than 0? In other words, when are the function values positive? Now, one way to solve this is to use a sign chart. And so we begin by finding the critical numbers. The critical numbers in this case are simply the roots. So we'll set 9 minus x squared equal to 0 and solve. 9 minus x squared is a difference of squares. So this factors 3 plus x times 3 minus x. Setting each factor equal to 0, we can see that there'll be two critical numbers. 3 plus x equals 0 or 3 minus x equals 0. X equals -3 or negative x equals -3, x equals 3. So there are two critical numbers here. There's two roots. X equals plus or minus 3. Next, we'll construct a sign chart. Now the roots will separate the regions where the function can be positive or negative. And because of the strict inequality, we'll use open dots here at the roots, -3 and +3. This breaks the number line up into 3 regions. Now we can determine if the function is positive or negative by testing values in each region. So let's begin by choosing some values. In this case, I'm going to choose to test x equals 5. And so in this case we have f of 5. Substituting that in, we have 9 minus 5 squared, which equals 9 minus 25, which is going to be negative. In fact, any number you choose in that interval will be negative, and so we'll indicate that with some negative signs above inside that region. Next, let's choose a test value in this middle region. I'm going to choose 0 in this case and test that. So f of 0 will be 9 minus 0 squared, which is this 9, and the result there, of course, is positive. Any test value you choose will result in a positive number. So I'll indicate that with pluses in that middle region. Next, we'll choose a value in this left region here. I'll choose x equals -5, and let's test that. F of -5 would be 9 minus -5 squared. Be careful with all your negatives here. That's 9 minus 25, and certainly the result there will be negative. Okay, so this here is the sign chart, and we'll use this to answer the question. Now the question asks for what values, for what x values is this quadratic expression greater than 0? In other words, when is this positive? So from the sign chart you could see that when x is in this interval, the results are positive. So I'll shade that in here and convert that to interval notation. In interval notation, we can say the answer here is all the x values from -3 to 3. Here we're asked to solve a quadratic inequality. In other words, we're asked to find for what x values will this function be less than 0 or negative. We'll solve this using a sign chart. And so the first step is to find the critical numbers. The critical numbers are simply the roots. So we'll set this quadratic equal to 0 and then solve. So 0 equals 9x squared minus 12x plus 4. This quadratic factors 9x squared factors 3x times 3x, 4 factors as 2 times 2, and the inner and outer products add up to negative 12 if they're both negative. And then a negative 2 times a negative 2 is positive 4. Setting each factor equal to 0, we can see we're going to obtain a double root. In this case, 3x equals 2, or x equals 2/3, occurs twice. So really there's only one critical number, there's only one root here, and that's when x is equal to 2/3. Next, we'll construct a sign chart. Now in this case, because of the inclusive inequality, we'll use a closed dot here at the critical number 2/3. And that separates the number line into two regions. Next, we'll test values to determine if the function is positive or negative in these regions. So let's begin with x equals 1. In this case, f of 1 will be equal to 9 times 1 squared minus 12 times 1 plus 4, or 9 minus 12 plus 4, which equals negative 3 plus 4, and that's going to be positive. In fact, any test value you choose in this region will yield positive results. Next, we'll choose another value here in this left interval, let's say 0, and test that. So in this case, f of 0 will be 9 times 0 squared minus 12 times 0 plus 4, which equals 4. And of course that's positive as well. So in both the regions the results are positive. Now we'll use the sign chart to answer the question. Now the question asks, for what x values is this quadratic less than or equal to 0? In other words, when is it negative or 0? From the sign chart we can see that it's really never negative, but it is equal to 0 actually at that one point there, the root. And so in this case there's really only one answer, and that is 2/3. Here we're asked to solve a polynomial inequality. To do this, we'll make use of a sign chart. And so we begin by finding the critical numbers. Now for a polynomial function, the critical numbers are the roots. So we'll set this equal to 0 and solve. In this case, we notice there's a GCF. The GCF is 3x squared. We could solve this by factoring. In fact, let's go ahead and factor out a negative 3x squared. Doing that, we'll be left with x squared minus 4x plus 3. Factoring further, we have negative 3x squared times x times x, 1 times 3. If they're both negative, that adds up to negative 4. Negative 1 times negative 3 is positive 3. So at this point we can set each factor equal to 0. And so negative 3x squared equal to 0 will give us a double root x equals 0. X minus 1 equals 0 gives us the root x equals 1. And x minus 3 equals 0 will give us the last root here, x equals 3. And so the three critical numbers are 0, 1, and 3. Next, let's construct a sign chart. And because we were given a strict inequality, we'll use an open dot at our critical numbers here, 0, 1, and 3. Now this breaks the number line up into 4 regions. And so we need to test values to determine where the function is positive or negative. To do that, we'll use the factored form of the polynomial. Let's begin with, say, x equals 5. Substituting in, we have negative 3 times 5 squared, which will be negative. We don't really care what the exact value is. We just need to determine if it's going to be positive or negative. And so when I substitute 5 into this factor x minus 1, we have 5 minus 1, which will leave us with a positive factor. 5 minus 3 is 2, and that'll be positive. And so multiplying a negative times two positive numbers, the result will be negative. And that tells me this first region here, the results will be negative no matter what x value I choose. Now let's test this second region. Let's choose x equals 2 and do the same thing. So f of 2 in this case, negative 3 times 2 squared will leave us with a negative factor. 2 minus 1 is 1, that's a positive factor. 2 minus 3 will leave us with negative 1, or a negative factor. A negative times a negative will result in a positive number. So in that region, we'll get positive results. Now, choosing a number between 0 and 1, say 1/2, we'll test that. F of 1/2 in this case, we have negative 3 times 1/2 squared will be negative. 1/2 minus 1 is negative. And 1/2 minus 3 is negative. Multiplying 3 negatives results in a negative number. Now finally, choosing a number in this last region here, say negative 1, substituting in negative 1, we have negative 3 times negative 1 squared leaves us with a negative factor. Negative 1 minus 1 is negative, and negative 1 minus 3 is negative. Again, multiplying 3 negative factors will result in a negative number. Once we complete the sign chart, we can next use it to answer the question. And in this case, we're asked to find the x values for which this polynomial is greater than 0. In other words, where is it positive? So from the sign chart, we can see that the x values between 1 and 3 result in positive values. And so the answer is all the x values between 1 and 3.